Hello everyone. Welcome to this fourth video in this series of learning how to analyze your data by yourself. It has been a good journey so far, and I believe that you have enjoyed this. Today we are going to be talking about data type, and data structure. Understanding data and knowing what types of data you are dealing with, it's very, very key and instrumental to fitting model to your data. So we are going to be talking much about data type, and then also we will talk about data structure, what the difference is between data type and data structure. But before then, please share this video, comment on it, and let's make it interactive. And also subscribe so that as I post new videos, you can also get a notification even without me sharing it to you directly on social media. So thank you very much. Now let's get into the business of the day. I want to do a quick preliminary and in the R environment so that we can have a good coding session. Now you see this by the right, the top partition or panel by the right, top right. It contains data that I have worked on previously. It is a good practice for you to clean up this environment so that you will not confuse some data or variable names with the ones you already stored in this environment. Anytime you open your R, try to clean up the environment because sometimes you can name the data, the current data you're working on, to have, the data you're working on, any of those variables can have the same name with the previous data you have worked on. And if the environment is not clean, there is high chance that you will call in a data or a variable name that you are not interested in, and it can really get things confusing. Okay, so first of all, I'll just tell you how to look up the variables even without looking at the environment. You can use the function ls to see all the data or the variables that have been stored in the environment. Here we have class score, and we have exam core, which is exam score, and then we have X. Here in the environment, you see them, no? Class score and X and exam score. And all of these have the different variables in them. So what we will do to clean up this variable is write a function rm, which means remove, and then you are listing all those things in the environment, which means ls. And then if you click, it will remove everything in the environment. I hope you understand that. And on the console, which is this place that I am highlighting, if it is full, you can easily press just Control L, and everything will disappear. Okay, everything will disappear from that. These are just basic things that you will really not get, but as you attend and listen to these lessons, common sense, practices have been chipped in here and there, and it increases your efficiency. Okay, so now let's continue. The first thing we will do, we will write is data. So what is data? Now, you shouldn't mistake this. This is statistics. It's not the MB you buy to power your phone or for you to be able to watch this video. Okay, so there are different definitions of data, but in statistics, in programming, and yeah, in data analysis, they are variables, or they are observations, they are values, they are facts, okay, um, and even text, okay, that can be used to draw conclusion. In its basic form, that is the definition of data. Data, for it to make sense, needs to be processed. All right. And when a data is processed, it gives what is called an information. It is this information that can be used to make inference, that can be made to make conclusions. Okay, so there is always this logical flow from data to information, and it is just first of all, you have the data. The data is there. For you to have the data to yourself, you need to collect the data, and from data collection to processing. And then from that processing, you have your what? Information. And then sometimes you can interpret this information and make conclusions. Now, the other thing we want to get into is data types. In case you are wondering how I brought this dialog box to the screen, it just Control Shift R and it gives you, it's just a form of inserting a node. You know, defining a data is easy, but it becomes more tricky when you ask somebody to list the data types, the types of data we have. You need to really differentiate between what a data type is and what a data structure is. Okay, so this brings us to data type and data structure. Okay, the data types, they are just a basic form of data of the same characteristics. And the data structure will have to group this kind of data based on their complexity, based on the component of the data set that you have. I hope you are understanding this. Okay, so we want to begin with what is called data types. Okay, and the commonest data types in our in data analysis include one, numerical data. Two, you have integer. Three, you have characters. The fourth one will be logical data. Okay, so we are going to be explaining each of these data type, and we will also give example of each of the data types. So let's begin with numerical data. This type of data consists of both whole numbers and decimal numbers. An example can include, if we want to create a vector. You remember how we created vector last time in the last class? If we want to create vector and we name the vector numeric, okay? Say numeric, when we place this, we're at 1.2, comma, 5, comma, 7, comma, 4.6, comma, 8, and then that. So if you run this, okay, so R is giving me an error here. Usually this is a bug that is related to R Studio. So all I can do is to restart the R session and then we continue. Hopefully we don't have the problem anymore. Let's clean up this and then we continue. Now it has disappeared. Now we have this. The values are what? 1.2, 5.0, 7 point this and other. So if you know something is happening here, all right? Something is happening here. R has introduced decimal points to even the values that are what? Whole numbers and integers. So it wants to put them on the same scale since the first value here is having 1.2. Okay, it wants also the others to have point. If you want to check the class of this data, what you can do is to say class and write numeric, the name of the variable where you save this vector, write this, and R recognizes this as what? Numerical data. Okay, so this is how a numerical data looks like. It contains decimal and it contains whole numbers. Are we okay with that? Now let's proceed to integer. Integer data, it's a data type that consists of only whole numbers. For example, you can talk of counts, okay? Counts are integer, and maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All these are integer. Um, there is something tricky about how R recognizes integer in a vector and how it recognizes it in a large data frame. If this was an integer data, uh, well, maybe I should just give you an example of what I'm talking about. Now, let's take a look. Integ. Let's put integ and run, and then we draw this. 1, 2, 4, 10, 20, 60, 70, 80, and 100. Let's run this. Unexpected numeric constant in integer. It's giving an error. Unexpected numeric constant in integ. Now you have an error like this. The first thing is for you to check your data, whether you have done the right thing. Okay, let's leave that there. Integ. Okay, here we have it. There is no comma between 80 and 100. Let's put the comma and run it again. And now you have it all. Okay. Yes, so we have this now. Let's take a look at the type of data we have in integ plus integ. What is it saying? It says numeric. Okay, so this is what I was trying to explain to you. There is a way R looks at numbers. Okay. In R, if you really want to create integer data, you have it to put L before each of these numbers. Okay. If you put L, the letter L represents integer in programming language like R. So if you are writing a common number like this, even though they are whole numbers, R still looks at them as numeric data. Okay. So what you need to do, you can tell R that, okay, this is actually an integer. All right. So you put L in front of all of them and then you run and then now you have it. Now R now recognizes it as what? As integer data type. But one confusing thing about this scenario is that if you have a complex data, maybe like the data you have collected from the field, and then you have values, for example, you have number of days, maybe like a number, day one, day two, day three, day four, day five, and you want to look at the effect or how things, your variables changes between the days, you will not have L before those. But R can tell you that they are integers. Okay, R will automatically look at it as integer variable or integer data. We will still revisit this again, and I need you to understand when we come to the different types of data, data structure, we will find out what this really means. But I just need you now to see that if you want to make a data of integer type, you have to put L before each value, before R recognize it, especially in a simple data format like this. Okay, now let's continue. The next thing is character. Character means what? Letters. Okay. So if I have a word of 2 or 3 characters, it means that it's a word of 3 letters. Well, in R, character data are actually words. They are strings. Character or string. It is also called string. Okay. So, and it means just words. So even a single letter can be a string or a character. Even a number can be a string or a character. But you really need to specify when you are creating it the way we created integer by adding L after each number. Now let's create character data. Here we have, let's have names. John, Rose, let's have Dixon, let's have Clement. Okay. Now let's run it. There is an error, and the error says object John not found. It's not only John that is not found. If you remove John, it will tell you object Rose not found. So it's not a matter of which particular name here that is giving the error. Okay. Now, R doesn't recognize this as anything. This is not any data type. You are not specifying it. It doesn't recognize just writing, okay, just words as words. You have to specify it. And in that case, if you want to specify a character variable, what you need to do is to put them in a particular word in inverted comma. Is that all right? Put it in what? Inverted comma. So I will put John, highlight it, and put highlight, put highlight, click, highlight right. Now, if we run it, it has successfully run. Take a look at this. It says John, Rose, Dixon, Clement. You see how this goes? All right. So now what this is, if we want to check the class of this data, which is car or char, whatever you call it, it's now what? Character. So you make character data when you put them in inverted comma. It is the same thing if you want to put hello, and it's not just single word. You can put sentence in this inverted comma. R still looks at it as what? As a character. A good example is the first code that usually they teach you when you are learning programming from the beginning. Um, let's put program and then write this, and then we have this, and we say put it in hello world. That is the first language that a computer knew how to to speak. Okay, hello world. Now hello world has run, and if you run this, it will tell you hello world. Bringing out these inverted commas will tell you that, oh, it is a string or a character. And if you check the class probe, it will tell you character. Do you understand now? Even if you put that in, if you include another, hello world, how have you been? Run it, class character. So provided they are in inverted comma, R looks at it as a character data or a string data. And I also mentioned that you can use single letter, word, and even a sentence, and even values. For example, if we put value here, like 2, R also recognizes it as character, provided it has that inverted comma in it. Okay, so now we have dealt with that. Another type of data is logical data. So this is basically some Boolean values that commonly include true and false. So if we want to write logic, and we write this true, false, You don't need to specify, just write true, just write false. R already recognizes it. It is one of the data type that R recognizes automatically, even if you don't specify. Just write the word and it will recognize it because it has it inbuilt already. We have this and we write this true, false. If we want to check the class of log, what does it give? Say logical. Now you have it, and we have dealt with this. Okay, let's try this and bring in the data that we have been working on from the beginning as an example data set, iris. Okay, if I have iris and I have it to be iris, this is the main data set. I'm just assigning it to iris instead of flower in the previous, or we can still write it flower. Okay, so we have this. You'll see this. Now, this is a data set of different variables, different vectors. Is that okay? If you remember, each of these are vectors, okay? And each of these names are what variables. So a big data set contains different variables of different vector types. All right. So if we bring this flower, we have each of these variable. How many types of data do we have here? Data types do we have here? We have numerical. We have, yeah, basically they are numerical and the and character. Okay, so I want to do something. I want to introduce numbers, and then we can see in a data. You remember I told you that here, if you are making or creating an integer, you have to put L. But I also mentioned that in a big data set, you don't need to put L because what you collect from the field, you just write your numbers. Example like serial number or number of days, number of months, or some counts. All right. So you don't need to put L for R to recognize that as an integer, provided you don't have any numerical value. Now, let me bring this. We have this. Let me introduce a number. Let's call it serial number. Now, do you still remember the rules to assigning variables? You should not have slash in between here. Now, let me leave this slash and you will see what will happen. So I put this, make this vector, and I say from 1. First of all, I need to check the dimension, the length of the data frame flower. I put flower. What does it give? Okay, so it has 150 rows and it has 5 columns. So I want to put a serial number for each of those rows, and so I need 150. I tell R, create a sequence for me from 1 to 150. You remember this? This operator is for sequence creation, so I run it. The problem here is there is a problem with the variable name. R doesn't recognize slash in this name. So you have to change that. You can either leave it as SNO or put an underscore. And let's run it. Now it has recognized it. And you have from 1 to 150. Okay. I also, okay, so what I will do now, I will combine this serial number with flower. And how that will be, I will write flower 2 and I will combine, which means C bind, column bind, C bind, um, S underscore NO dot, yeah, and flower. Let's run it and let's view it. Now we have the serial numbers assigned to the data. See its serial number 1, 2, 3, all the way. Now we will see this, and also I want to add some names Okay, let me add names. If I want to add names, maybe names of people for us to see how this data that we have, data types that we have exemplified, how they behave in a bigger data format. All right. So name, they see, and I have, let's say John, let's say Grace, let's say, yeah, Dixon, let's say Mercy, let's say um, Friday. All right. There's something wrong with this. You know, these are names. These are characters I'm forming, I'm creating. They don't have this. They don't have the character. What are we use to recognize them as character? So if you run it, it will not give you anything. What I need to do, I just need to put them in inverted comma, all of them. And now I have it written. Yeah, so 1, 2, 3, 4, 5. Now let's merge it also with this one at the end. Let's merge name. Now it has merged, okay? So it's not a complete name. It repeats itself after the fifth one. It repeats until it fills in the whole 150 um, rows of the data. But at least we have what we have a data that we can check. Now, number one. So this brings us to checking the variable names. All right. Let's check in this data flower. If we want to check the class of each variable in the data, flower 2, that is flower 2, and do the assignment, or assessor, and you write serial number. What is the class of serial number? It says integer. You see what I was talking about? There is integer, it's a serial number. This time around, it is recognized as integer even without putting L. So in a bigger data frame, R will know that, okay, this is whole number, this is an integer, unlike when you were creating the integer in its most simplest format. All right. So that is that for that. Now I want to also create or check the class of the name we created. Name. Now it says what? Character, because we made it and we say it is character. And you also remember that the other ones, the separ length, separ weight, separ whatever, they are numeric. So if we take one of them and say separ length, put it in here, we have numeric. You see how that plays out now?